Good day. Today I will be presenting machine problem 2, specifically set A, or number 1, set A. So the problem given is write a MATLAB script to determine the value of cosine pi over 4 using the Maclaurin series expansion of cosine given by cosine x is equal to 1 minus x squared over 2 factorial plus x to the power of 4th over 4 factorial minus x to the power of 6 over 6 factorial, so on and so forth. Add terms until the value of the proximate error estimate, E sub a, falls below an error criterion conforming to a 3 and 5 significant figures. Compare your results to the true value of cosine pi over 4, my bad, by computing the true relative percent error, E sub t. So let us proceed first to the Maclaurin series of cosine x. And then we get it by taking the derivatives to the nth. So then we look for the pattern. So the first derivative of of cosine x is negative sine x, which is 0. And then the second derivative will be negative cosine x, will be negative 1. And then the third will be 0. Then the fourth will be 1. So we see it cycle back to 1. So therefore, we take into account it, take it into account and create a formula out of it. So this will be the formula of cosine of x. And summation n is equal to 0 to the infinity, negative 1 to the power of n multiplied by x to the power of 2n over 2n factorial. So let us now proceed to the next slide. So in the program, the iterations will only stop, or even if you chart it down, it will only stop if E sub a is less than E sub t. But as long as E sub t is less than E sub a, it will never stop. So E sub t is a constant, or it has a formula where 0.5 times 10 to the power of 2 minus n, where n is the n in Maclaurin series. And then E sub a is equal to the present value minus the past value over present value times 100, where the value is the value of the Maclaurin series in terms of cosine x. So the value of x is equal to pi over 4, so it will be equal to 0.7854. Now I have taken the liberty of putting it in a chart. So here, as you can see, where n is equal to 0, cosine pi over 4 is 1. Since by using this, wait for a minute. Since by using this pattern, we can see that where n is equal to 0, we can see that negative 1 multiplied by 0 will just be 1. And then multiplied by x to the power of 2n, which is 0, over 0 factorial. Over 2 times 0 factorial. And we all know that 0 factorial is 1. So therefore, 1 times 1 is equal to 1. And then same goes to the same goes to the next one, where n is 1, so on and so forth. As you can see here, cosine pi over 4 is equal to 0.69157, and then the second n is equal to 2 will be 0.70742, and then 3 will be 0.707103, then 4 will be 0.707106. And then here E sub A, so you can, as I said before, it will never stop until E sub A is greater than E sub T. E sub T. Okay. So let us take into account at the third. Now let us use, oh, but before everything proceeds, let me first show you how do we how did we get this 0.05 and 0.0005. Since we are using MATLAB, let us take the advantage of it. So since the formula for it will be the formula of it will be, wait for a moment. The formula of it will be 0.5 times 10 to the power of, open close parenthesis, n, 2 minus n, where n is the iterations. So, the significant figures in this case. So, as you can see in the first problem, wait for a moment. As you can see in the first problem, it will conform. It falls below an error criterion conforming to 3 and 5 significant figures. So at first we must input 3 since it needs 3 significant figures. So let's call on the command window where it can act as a calculator. So n minus 3 is equal to 0.05, as you can see. This is 0.05, and then let us repeat the same to 5. And let's just, okay, so 5.000 e minus 0.04. So it will be times 10 to the power of negative 4, which is 0.005. And since EA, E sub A is is equal to the present value minus past value over present value multiplied by 100. So we can solve it here as well. So as you can see, let us just skip to the n is equal to 2 and n is equal to 3. Since 0.5 befalls on that, the error, the E sub t is larger than E sub a. So therefore the criterion stops there. So 0.707103 minus 0. Oh, okay. Where did my, wait for a minute. 0.70742 over 0.07103. So we multiply it by 100. Multiplied by 100. So we get 0.045. And then, so that's what we get in in the chart here, in the chart where n is equal to 3, E sub A is equal to 0.045, and then it is less than the epsilon t, or the true percent error value, which is 0.05. So that is where the iteration stops. And then at here, we do the same thing, same principle, where n, the value of cosine pi over 4, where n is 4, then minus cosine the value of pi over 4, where n is 3, over cosine the value of pi over 4, n is 4, and then we multiply it by 100. We get 0.004, which is less than 0.005. So that is the two solutions, or the two answers, where n is the iteration stops where n is equal to 4, since we count down the 0, and then at 5 significant figures, the iteration stops where n is equal to 5, or the iterations of it will be 5 and 4. Now let us proceed to the MATLAB. I'm sorry for the slight lag of my computer. And then let us call back this guy. Sorry. Okay. Get full screen. And then let's clear it out. Now let us, before I run this, let me first explain to you what I did, as I just did on the PowerPoint. So here we see ES, which is E sub S, epsilon sub S, which is the true percent error value. And as you can see, I just put it down in that language where the program can be understood. And then I put E sub A, epsilon sub A is equal to 1. So I put it as 1 since I have a while and for loop. So while E sub A is greater than E sub S, since the E sub A is not yet known, let us just put an initial condition which is greater than it significantly. So we all know that E sub S, where n is equal to 3, it will be 0.05, and 1 is significantly larger than 0.05. Now in this, so we clear out first everything, where out sub past is equal to 0, and out is equal to 0, and I is equal to 0 in the loop. Of course, we cleared everything out so that when it runs, since the program runs line by line, as it runs, everything is cleared out. So while E sub A, EA is greater than ES, the I is equal to I plus 1. So what it does is it just adds up everything. The loop, the I will be added plus 1 up until it stops. So again, out sub past is equal to out, and then out is equal to 0. Again, it is the executed line by line. So we clear it out again, and then in the for loop, where k is equal to 0 to I minus 1. So I minus 1 is just the regressive number, which is 1, 2, 3, 4, 5, 6, 7, 8, so forth. And then we plot out the Maclaurin series, which is -1 to the power of n. At this case, we put k since n is tasked as the number of significant figures. And then we put k, then multiplied by x to the power of 2 times k over factorial 2 times k. And then the for loop will end. So while the for loop ends, the while loop is still not ending, still hasn't ended yet. So EA is equal to the absolute value of out minus out subpast, where EA here in this case is the condition in the while loop. So if the EA down here at the end if EA is less than ES, the program stops or the while loop stops. And then here it will display EA since it is needed in the while loop. So I just at the end or at the while loop end, I added f is equal to I plus 1 since I started out as 1, where n is equal to 1 and not take into account 0. So 0 is just you just add 1 in order to make the criterion the iteration the same to the one at the chart. So let us run it. The value of n here in A for a minute. The value of n will be 3 and 5. And then the value of x will be pi over 4. So n is equal to 3 pi over 4. As you can see, the value of cosine is equal to 0.7854, which is cosine multiplied by 0.7854 is 0.7043. And it took 4 iterations to conform with the stopping criterion of 0.02%. So as you can see here in the chart, okay, so the iterations has been succeeded since they're both the same, where n is equal to 4, or as well as the iterations, not just here in the chart but also in the program. So 0.045 is less than 0.05. So the error is when you subtract both of them. Or no. The error is when 0.05 is less than 0. 0.045 is less than 0.05. And it can be computed by, let us go back to as I said earlier, it can be computed by the present value minus the past value over the present value. Now let us run it again and see where n is equal to 5. 5, then pi over 4. Okay, so as you can see, it took 5 iterations to conform with the stopping criterion of 0.00046. So here in the chart, you can also see it. So the n is equal to 5 since 0 is counted. Wait. Oh yeah. Yeah. I'm sorry. So n is equal to 5 since 0 is counted, and then 0.004 is less than 0.005. And here in the program, if I ask for the value of EA, that is 4.6 to the power of negative 4. E negative 4. So that is 0.004, which is really precise to the chart that has been computed analytically. So yeah, in other words, the program works. That is all. Thank you.